The Internet of Things, or IoT for short, has become a backbone in many industries like smart home systems, monitoring systems, industrial control systems, weather stations, and many more. It is a system that is based on sensing, collecting, and sharing data using sensors. However, using IoT technology generates a large amount of data like text, numbers, audio, video, and images. This data needs to be transferred, processed, and stored in a cloud server. It also needs to be queried and updated on demand. A flexible database management system is an important target to implement this challenge. The main objective of this paper is to find an effective way to manage and store large amounts of heterogeneous data in appropriate DBMS. This objective is implemented by performing experiments to compare the performance of MySQL and MongoDB uh, on basis of metrics such as latency and database size. The authors cite similar work comparing SQL and no-SQL DBMS and their limitations such as using a fixed number of sensors, examining only one type of MongoDB schema, etc. This paper is proposed to solve a lot of these previous limitations. Different scenarios with different number of sensors, different cloud servers with hardware specifications are examined. Two different schema types, which are reference and hybrid, are examined for MongoDB. Uh, Also, a statistical analysis is introduced to predict the best DBMS depending on data size and server performance. Elastic Compute Cloud, or EC2, is used for the implementation of this comparison. It is a VPS with resizable and almost unlimited storage. Three types of instances were created for this comparison, referred to as VM1, VM2, and VM3. The database stores information about elements of air pollution indoors and outdoors. The data is collected through four stations, each having 12, up to 12 sensors, which each sensor sends data to cloud uh, at the rate of 1,000 records per transmission. Different scenarios are carried out based on increasing number of sensors on each station from 1 to 12. The latency of both DBMS in insert and select queries was compared in different scenarios. For insert query, in the first scenario of VM1, where each station has only one sensor, MongoDB decreases the latency compared to MySQL by 83.2%. Uh, the number of sensors in each station is increased, and in the last scenario, which is each station having 12 sensors, MongoDB decreases the latency compared to MySQL by 97.7%. Using VM2 improves the performance of MySQL by 29% over using VM1, while it improves the performance of MongoDB by 23%. Using VM3 improves the performance of MySQL by 43% over VM1 and 26% over VM2, and it improves the performance of MongoDB by 35% over using VM1 and only 8% over using VM2. In case of selection queries, VM3 has an average improvement of selection latency of 63.2% over VM1 and 22.5% over VM2 in case of MySQL. In case of MongoDB, the improvement over VM1 is 38% and over VM2 is 12.3%. This shows that MySQL is affected more than MongoDB by the instance performance. Also, the results show that MongoDB is faster than MySQL in all scenarios implemented on all instances VM1, VM2, and VM3. Conclusions. The results show that increasing workloads in case of MySQL leads to considerable loss in performance compared to using MongoDB. There are cases where the reference model of MongoDB is better than MySQL in terms of both latency and database size. But on the other hand, there are other cases where MongoDB is better in terms of latency, but MySQL is better in terms of database size based on the database workload and the number of connected sensors. However, the hybrid model of MongoDB is better than MySQL in terms of database size as well as latency. Uh, the statistical analysis shows that non-linear regression is better than linear regression for estimating latency in both MongoDB as well as MySQL. In the future, a hybrid model between MongoDB and MySQL can be implemented and compared against MySQL and MongoDB. The evaluation process can be performed using big data workloads, and the estimation process can be implemented using neural networks instead of the regression process.